Good evening, everyone. In this lecture series, we are going to discuss about the topic basic electrical quantities. Before entering into the topic, we must know the basic electrical quantities. What are the basic electrical quantities? So here, the basic electrical quantities are charge, current, voltage, and power. Suppose if we are taking the electricity, it is like a water hose. The voltage, the pressure, that is termed to be as the voltage. That will be measured in terms of volt. And the size of the hose will be as current. So current is defined, the unit of current is amps. So we can say this as ampere or the current, and the resistance will be measured in ohms. The SAN uh, is termed to be as the resistance. So just we are incorporating this in terms of the electrical quantities. The next one, electric charge. So we know that the atom consists of the protons and the electrons. Protons is nothing but the positive charge. Electrons is nothing but the negative charge. What do you mean by electric charge? Means that is amount of electricity that is present in a body. The unit of electric charge is coulomb. The charge, the point, it can be positive or it can be negative. The next one, electric current. Electric current, the unit of current is amperes. We know that it is defined as I. The definition for the electric current is rate of flow of electric charge. The unit is ampere. The DC is nothing but constant magnitude and direction. AC is nothing but varies with time. So from the figure itself, we can say we are having these several types of the current, such as direct current, that is DC, sinusoidal current, AC. In the third figure represents the exponential current, and finally we are having the damped sinusoidal current. The next one, voltage. So what do you mean by voltage and how we are going to measure this voltage? Means the definition for the voltage is work done per unit charge to move a charge between 2 points. Between the 2 points, the work work done per unit charge. So the unit is volt, and which force that causes the current to flow. So we are driving the force. So that is termed to be as the voltage. Power. We know that the power, the rate at which the electrical energy is consumed or it may be generated, the unit of watt is the unit of power is watt. We know that power can be measured in terms of voltage and current. P is equal to VI. So I is equal to V by R. Just substituting in the above formula, we will get V squared by R. So we can write V by R is equal to I. So I squared into R. So this is the representation of the power. The resistance. Suppose, so what do you mean by resistance? Resistance, it is nothing but the opposition offered to the flow of current. We know the resistance unit is ohm. Uh, what are all the factors that affecting the resistances? Length, area, material, and temperature. So these are all the colors that has been indicated, and the digit is given to that of the particular color, and the multiplier will be 10 power 0 to 10 power 9. So the tolerance will be gold and silver. So here the tolerance indicated as 5% and 10%. Next, the capacitance. We know that what is the purpose of the capacitance. Capacitance, it is nothing but ability to store the electrical charge. So, what is the unit of the capacitance? Farad. So, we are having two types of the capacitors. One is parallel capacitor, another one will be the series capacitor. In case of the parallel capacitors, we are going to increase the area, that is increasing the capacitance. And in case of the series capacitance, we are increasing the distance so that the capacitance value will be decreases. So when C increases, A by D, it increases the capacitance if the area gets increased. Increasing distance, that will decreases the capacitance. And next, inductance. We know that what do you mean by inductance means it is a property of the conductor to oppose the change in current. The unit of inductance is Henry. What is the effect that has been produces means it produces induced EMF when the current changes. Then suppose if the current is increasing, what happens to the voltage means it opposing the change that is created by the magnetic field of the coil. So, as we have discussed about some of the electrical quantities, we know that what do you mean by current? It is a flow of charge, so its unit is ampere. While coming to that of the formula, I is equal to dq by dt. Voltage, it is nothing but potential difference. Unit is volt. The resistance, opposition of current. The unit is ohm. Inductance, property to oppose the change in current. Frequency, we are measuring in terms of the cycles per second, that is F is equal to 1 by T. The energy is electrical work done. The power, it is nothing but rate of energy transfer. The conductance is ease of current flow. Capacitance is used to charge, and the electric charge, it is nothing but the amount of electricity. So these are all these some of the basic electrical quantities we have discussed in this lecture series. Thank you.